Welcome to WebRTC Tips by WebRTC.Ventures. I'm Aaron Syme, CEO and founder of WebRTC.Ventures. In today's tip, Hamza Nasir from our development team is going to talk about attention detection in video conferencing calls. And he's going to show a really cool demo of how he and a colleague were able to build in detection of whether or not someone in a video conference is paying attention or not. And they did this on top of the Vonage Video API. It's a really interesting application and demo here. So let's get right to it. Here's Hamza Nasir talking about attention detection.
Today, we're going to be exploring a neat feature that you can build with Vonage Video APIs. It's called attention detection. So let's first start with the why. So why would we want to build attention detection? Why is this needed in today's world? So we have a post-COVID, the world has moved to a more remote point of view where basically conferences, education, every sector that you could possibly think of is moving to online video conferences. And for some, for example, in education, when the professor or the teacher is delivering a lecture, attention detection is key so that they know that what parts of their lectures is making the audience snooze or versus which parts are making them jump and actually retain attention. That's one use case. For another use case is keynote speakers, right? So I'm sure a lot of you have tuned into the presidential debates that happened a while ago and many other debates. So for those speakers, they could deliver their speeches and use attention detection to actually kind of gauge and monitor their speeches and see which parts they could improve versus which are already good or actually spark interest in the audience. There's also multiple studies done in the advertisement and marketing sector which draw correlation to head pose estimation and water retention or whether somebody's going to buy a product. So and head pose estimation is going to be the primary factor, primary thing that we're going to use to basically calculate attention. And there's many more applications for this. These are just some that are fairly common in today's world. So before we jump into the more interesting demo and everything, let's just talk about how we're going to achieve this. So we're going to use TensorFlow's media pipe. It's basically a machine learning model to kind of make a mesh of your face. And and by that, it would basically take your face or a picture of a face of your face as an input and basically create these landmarks, these data points on your face, which we will use to calculate attention. Now, we don't need all of the points on your face because there's quite a lot of them. But what we're interested in is the roll, the yaw, and the pitch of your face. So to calculate the roll and the yaw, and in a second you'll see what you'll be able to visualize what the roll and yaw is. But basically, to calculate this, we just need the 2 points in the corner of your eye. So your one corner on the right eye and the one corner on the left eye. Similarly, to calculate the pitch, we just need 2 points, one at the top of your face and one at the bottom of your face. So this picture, this GIF was generously given to me by one of my colleagues who actually worked on me with me on this. So as you can see, this library creates, these are the data points that it creates based on your face. And right now you can see that Rahul is going to, so now this is the pitch. sorry, this is the yaw, and now this is the pitch. So up and down. And then if he turns his face like rotate clockwise or anti-clockwise, then that's going to be the roll. So, okay, great. We have the roll, we have the yaw, we have the pitch, but then how do we actually translate this into an attention score metric? So we basically we were influenced by this paper by these PhD students that basically they did head pose estimation, but they used neural networks. We used a much simpler form for that, but we used their attention score algorithm, which is basically you calculate these angles between the yaw and the pitch, um, and the roll, and you translate that angle to a 0 to 2 based score. And then you multiply everything together to basically get a value from 0 to 4 based on attention, based on the angles. Uh, so you can make like you can kind of play around with these categories and this algorithm part, where you can make it more strict or you can make it more loose when it comes to giving you an attention score metric. But we basically made 4 categories, which is we said, okay, 0 to 1, no concentration, 1.1 to 2, low concentration, 2 to 3, medium, and then 3 to 4, very high or high concentration. This isn't how, like, this is something that you can just kind of play around with and see what works for you. And I'm pretty sure that for my demo, I've actually changed some of these values. But that's how you can categorize uh, these attention values. Okay, so now for the fun part, how do we integrate this with Vonage Video APIs? Vonage, just to give like a quick intro on what Vonage Video APIs is. Vonage Video APIs is a CPaaS platform which allows you to build a video application, video conferencing application from scratch in just like a couple of lines of code, right? Um, so a key part of that library is that uh, when there's a concept of publisher and subscriber, but this is something that I don't want to get into, and I'll assume that the audience is familiar with this. But basically, the publisher, so me, I will uh, m- I will use my stream to calculate an attention score for myself, and then using Vonage's signaling API, I will send that to everyone else in the call. So basically, I'll calculate my own value. Let's say it's 2.7, and then all of the other 5 people in the call, I'll be like, hey, my attention right now is 2.7. Um, so the number of times you run this per second is effectively your frames per second that you're getting information for. So if you're publishing your stream at 60 frames per second, then yeah, you could essentially run this 60 times per second. But if your stream only supports 30 frames per second, then running this 60 times a second you're just losing computational bandwidth. So there's some drawback to this architecture. So another use case could have been that, hey, like I just run this model on every one stream in the call on my machine. That would take a lot of CPU and GPU, and that would potentially crash the application. So this way, you're using more networking bandwidth, but you're actually saving on CPU and GPU per usage per participant. So now for the fun part, for the demo. Um, so this application right here is built with basically these couple of sample applications that Vonage provides you, and I basically put them into one and built the attention detection stuff on top of it. So if you'd like to run this demo on your machine and just kind of play around with it, this is the link that you could follow, and just clone the repo and run it. But yeah, okay, so demo time. Over here, hello, hi everyone. So over here, you can see that it looks like a normal video conferencing application, but I don't know if you can see, but there's a label over here which tells you what kind of attention it is and the value. So, like I said, this value goes from 0 to 4. Um, and the border is also kind of indicative of what the attention is right now. Now, if I look dead center and if I'm like completely focused, you'll see that it's saying perfect attention. But if I start to kind of gaze away slowly but surely, you'll see that it just the attention value just drops to 0. And this can be in any direction. It can be up and it can be down. So that's how it records attention. And it's a numerical value. So uh, that kind of gives us more uh, like data to play around with. I love this project because, first of all, me and my colleagues came up with it in sort of a hackathon. And what we built was that we had AWS transcription. So we were actually able to map the history of the call since it started, and with the exact words of the presenter, map an attention value to all of the participants. So I would be able to tell if what I'm saying right now is boring you or if it's actually interesting you. And I think that's incredible. That's it for the demo. And now I'm going to turn it back to Aaron.
Thank you, Hamza, for sharing that tip with us on WebRTC Tips by WebRTC Ventures. If you are interested in building a live video application, contact us today at WebRTC.ventures. You can also follow us here on YouTube and on Twitter at WebRTC Ventures for more content like this.